Hi, hello, welcome to our channel, DE Academy. Before starting, we would like to say that we have done a lot of research on this concept, and it includes hours of work, so we request you to appreciate our work by like, share and subscribe. So, let's start. Today we are going to present a seminar on automatic sun tracking system, in partial fulfillment of requirements for the award of the degree. Presented by DE Academy, and under the guidance of Professor, DE Academy. The contents that we're covering here are Introduction, Solar Tracker, Need for a Sun Tracking System, Basic Components, Working, Applications, Advantages and Disadvantages. At the end, conclusion and few references. Starting with Introduction, in remote areas the sun is a cheap source of electricity, because instead of hydraulic generators it uses solar cells to produce electricity. Extracting usable electricity from the sun was made possible by the discovery of photoelectric effect. Photoelectric effect makes solar power possible. It is the principle referring to when electrons are released by photons making an electrical current, which is what makes it possible for harvesting of electricity through the use of solar cells. Subsequent development of solar cell, which is also known as photovoltaic cell, is an electrical device that converts the energy of light directly into electricity by photovoltaic effect. The output of solar cell depends on the intensity of sunlight and the angle of incidence. It means to get maximum efficiency the solar panels must remain in front of sun during the whole day, but due to rotation of Earth, those panels can't maintain their position always in front of sun, and this problem can be solved by tracking the sun's position. So, what is solar tracker? A solar tracker is a generic term used to describe devices that align various payloads towards the sunday. Here the payloads are usually solar panels, parabolic troughs, which is one type of a solar thermal collector, that is straight in one dimension, and curved as a parabola, is the other two. Another payload is Fresnel reflector, which are capable of concentrating sun's energy to approximately 30 times its normal intensity. So, the system focuses on the optimization of the electric energy produced by PV cells through the development of sun tracking system. Now the need for a sun tracking system. The sun keeps on changing the angle from 0 to 90 rising, and 90 to 180 declining. In a year of 365 days the sun moves approximately 22.5 degrees north to 22.5 degrees south of the equator, and moreover the position of receiving maximum radiation comes only once in 24 hours. For this fluctuation factors the fixed solar panel does not give higher efficiencies. So, the tracker system helps the solar panels keep oriented to the sun at the optimum possible angle and improve the efficiency of solar panels by 30%. Some basic components are solar panel, where it is mounted with sensors, stepper motor, which is brushless synchronous motor, and it can drive one rotation in many steps. The linear actuator is attached to the panel for angle adjustment. A master microcontroller, 89C51, which controls the automatic operation of tracking system. At last a display unit, which is optional, and interfacing cables. Coming to basic principle of working, the basic fundamental block of system are 6 sensors, and their operation depends upon the intensity of light falling on solar panel. The sensors being used are 2 sun tracking sensors, STS, nighttime and daytime fault detectors, NTFD, and DTFD, and night and cloud detection sensors. Starting with sun tracking sensors, these 2 sensors are mounted in V-shape exact in the middle of solar panel. Basic tracking operation takes place in 3 steps. In step 1 the sun is in front of solar panel, so both sensors STS1 and STS2 are getting same amount of light. In step 2, after some time as the Earth rotates, the solar panel gets repositioned with respect to sun, and STS1 obtains less amount of light. At this point STS1 sends signal to the microcontroller. Then the controller rotates motor, which in turn rotates the solar panel towards the sunday. In step 3, the solar panel is reoriented and the process continues until the end of the day. In routine work of the system, if a general fault occurs during night time, then the next morning it would not work. So, the sensor nighttime fault detector detects whether the solar panel is ready for tracking or not for the next morning. Except some special condition like cloudy weather, the system is supposed to track the sun whole day. If the panel stops rotation, then this type of fault is detected by daytime fault detector. In cloudy day, light intensity is less than a normal day. Similarly, during night, light intensity is far less than cloudy day. So, the night and cloud sensors work on this principle to detect the event. In case of night event, the microcontroller stops all operation of the system and repositions the solar panel towards east to track the sun for next morning. Output of all these sensors given to microcontroller, and it executes predefined task to reposition the panel towards the sun's position with help of stepper motor. Some of the important applications of the system are that it can be used for small and medium-scale power generations. Also used for power generation at remote places where power lines are not accessible, and used in domestic backup power systems. The system has both advantages and disadvantages. Coming to advantages, it is a one-time investment which provides higher efficiency and flexibility comparing to other sources. The system helps in reducing emissions, and that contributes against global warming. The bulk implementation of tracking systems helps reduce consumption of power by other sources, and it also enhances the clean and emission-free power production. Switching to disadvantages, the initial investment is high on solar panels, and it's a bit difficult for servicing. Moving parts and gears will require regular maintenance, and over a long run may require repair or replacement of broken parts. With all the details, I would like to conclude. On one hand, we can see the world's energy resources depletion to be a major problem, on the other hand global warming, which is a major concern. So, switching to solar power, which is clean and green, and enhancing its efficiency by using sun trackers, is a great option in the near future. These are the few references helped me to work on this concept. Thank you for giving me this opportunity, and thank you for patience listening.